Welcome to Circuit Analysis. Today we're going to be going over how to make a custom footprint for your parts. So we've already talked about making a custom symbol, link in the description, but we'll make a real quick symbol for this specific part. And we'll make the PadStack, which is they have it broken up into first you make the pads and then you make the footprint and you link the pads to the footprint. Then if you make it all the way to the end, we'll have a bonus of how to download a lot of pre-made packages online for free. So let's start with this LM741 op-amp datasheet. This is a classic. If you go to page 15, they've got some information for this through-hole package. So we'll be using that. A little tip I'd like to mention, if you go to page 3 here, you can see here is the package. And we can screenshot that and then get a paint editor. I use paint.net, and you can save that file. And now we can go into our main program here and place picture. This way we can just keep this note here while we're working on this and make sure we keep everything correct with the pin numbers. We'll start with the part we already created here. So I'm going to close it. We'll right click on it, copy it, and then we'll rename this one. Call this 741. And then we can paste the other one back in here with Control V. So we saved the other part. We have a copy with a new name. We can double click on that. And we'll just have to change these pin names around a little bit. If we want to make it so we can make this plus a little better so it's not snapping to these grids, we can go Options, Preferences, Grid Display, and uncheck this pointer snap to grid here under Parts and Symbols grid. Now you can move this more precisely. Something like that. On this one, we need to get rid of all these pack shorts, except for this here. We do have 2 pins for this offset null. So we'll make 1 the primary pin, and 5 will be the hidden pin. Now, if we edit the pins, we can then make all of these pin ignores. We want these to be no except for 8 because it's not connected. And 5 because it's the hidden one. And I've listed all of the pin types here, except this NC one we can change. We'll save this and go back to our schematic here. Get rid of this old part. P to place a part, and our library is called Library 1. Next, we're going to make the pads. So for that, we use the PadStack editor by going to Start, Cadence PCB Utilities, and then PadStack Editor. Now, one thing I'll point out here, this is, I think, the standard directory that has a lot of the built-in, if not all the built-in footprints and pads in it. So it's Cadence PB 17.4, share, PCB, PCB lib, and then symbols. And this one, you can see all these DRA files are the footprints. And then if you scroll down to the bottom, there's all these .pad files. So these are the pad stacks. So you could search here for .pad if you wanted to filter those out. And there are a whole lot of pads already in here, so chances are you could just use one of these pre-made ones, but it's pretty easy to make your own. So we'll just make our own here. Back to the data sheet. We see here on page 15 that this has a pretty standard 100 mil pitch between the pins, and the pins widths are in the range of 15 to 21 mils. So that means this top part here says 70 wide here, 45 to 70. So we're going to want to make our hole size bigger than this and smaller than this. So that's going to put it in around like 35 mils. And if we do 35 mils, we're going to want the pad to be at least 20 mils bigger. So that's going to be 55, 60 mil kind of range. Now we got to fill out each of these tabs. So let me show you my notes on that. Here's the notes for through hole and for surface mount. And then these are all the names of the tabs and which items you need to make sure you fill out. So here we got them side by side to make it a little easier on ourselves. So the first step is through hole pin and circle right here. So also note here the units are in mils with 1 decimal place. So then we go to the drill page, and for that we were going to do 35 mils. So we'll do that here. The tolerance, I actually just leave it 0 a lot of the time, so let's just leave it 0. The next one is drill symbol. So that's over here, and that one we want to do circle, and the diameter is going to be 35 again. So the next one is design layers. So over here, and we have all these columns with these rows we want to do. So when we click on that, it'll give us here what the pad size is going to be. And we want these to be at least 20 above the 35. We'll just do 60. Now you can see that there's the hole in the middle and the pad. And once you do one of these, you can click on it and do Control-C for copy. And you can use the arrow keys to move around and do Control-V, Control-V, Control-V. So now I have this note here to make thermal and anti-pads 50% larger than these regular pads. So that would be around 90 mils for that. We can do Control-C. You can also select a big group by holding down your left click button and dragging and then letting up, and then you Control-V to put all of them at once. Next, we're going to do the mask layer. So here we have solder mask top and bottom. We click on that. It's more of the same here. We want the solder mask to be just around the pad. So put 60 for this one. And bottom 60 as well. Now there's these options here in this summary page, but we're pretty much done now. So we can do this file save. Now this brings us back to that default folder that we were looking at before, where all the other pads are saved. And you can see here's actually one that probably would have worked. It's 60R40TH. So 60R40 means like 60 mils for the pad, 40 for the hole, and then TH is through hole. So they've got a few different pre-made sizes here. So ours, I think we'll just put it actually in our project folder. So let's go here To our project folder, it's just in C:\test. And we're going to use the same convention. So we'll do 60R35TH. We'll save that here. Now just for kicks, let's pretend we're doing a through-hole pin. So we'll close this and we'll reopen the PadStack editor and just do one of those. So you want to start off with pin rectangular, SMD pin, rectangle. And now that grays out all these drill options because we're not drilling anything. So we can just go straight to the design layer. And here we just put the pad size in here. So if the width, maybe it's like, 40 mils by 60 mils. I'm just making stuff up here. And then in this case, we just go to the mask layer and we just fill out solder mask top and bottom with the same thing. 40, 60. We can save that one. Just call it 40 by 60 surface mount, something like that. So after making the pad stack, we open up the PCB designer here. We're going to go File, New, and there's the symbol wizard you can check out, which saves a little bit of time, but we're just going to do the regular package symbol. And we're going to save it here to our project folder. And we're just going to call it LM741. We'll use the defaults here. This is our blank footprint. So we'll do layout and pins, which is also this button right here. And then these three dots here open up the PadStack selector. So we type 60 with a star, that'll search for the pad we just made. And ours is 60R35TH. Now you notice it does a weird little thing here where some of these letters are made uppercase and some of them are not. Like in our project here, this is 60 small r 35th, and this one has a big R, and it's done it with the other parts too. So I'm not really sure why that is. The other thing I'll point out, it seems like it's picking it up here, but if you're having trouble with that, there is a key folder, if you call it symbols. I think that helps it pick up your symbols. So you could move these guys into here and save this footprint into the symbols folder as well. But anyway, this looks like it's working. So we just clicked and placed it, but it's very tiny. So I'm going to do Control and scroll to zoom in. There's our first pad. Back at the data sheet, we see that the pins go from the top left, pin 1, down, and then a wrap around and end at the top right with pin 8. And if we go back to page 15, we see the package here. It helps if they have a recommended pin layout with the footprint, but this one doesn't. So you can see it's the standard 100 mil between the pins, and then the distance here on the top between the pins is 325, and on the bottom it's 430. So you probably go between that about halfway, since the board's going to write up here, and call it about 375 mils. Now we can just place these guys down here. So when you're done putting all those pins down, the shortcut for being done is F6. You can right click and select done. Now that goes away. I did do a video I'll put in the description about doing a bunch of custom shortcuts that make it a little easier for working in this, because it's kind of an unintuitive interface. For now, I'll try and stick with the built-in commands. But right here you can see, if you look at these coordinates down here, these guys here on the Y are 8800, 8700, so the grid is set to snap to 100 mils. So these guys are all in line going this direction, and we just need to move these guys over this way. So this is 200 mils from here, 11,600 to 11,800. So if we select all of these guys and right click and do move, we can go to here, but now we got to get 75 mils further. So the two options for doing that is change the grid. We can go setup, grids, and then over here, we can just change this to 25. 100's pretty rough anyway. Now when we do move, we can get it over here. So this one is 11,600. This is 12,025. So that's actually too far. We want to go 11,975. There we go. As an alternative, we can use the command line to move a pin to a fixed coordinate. But before I demonstrate that, let me show you this. If we go to Setup and change Drawing Origin, then we can right-click on this pin and do Snap to Pin. And that'll put the drawing origin on this pin. Now see down here, it's 0, 0 on pin 1. So that'll make it a lot easier to move these guys around. So to move something on the command line, you can select it, right click, enter the move mode. I'm gonna move this over so you can see the command line. And it was right here at 0 and 375. So if we go into the command line and just type X space in the new coordinate, so we'll call this one 0 and then Y, we can just put 400 here. That just moved it to 0 and 400. I'm going to do Control Z to undo that, but you get the idea. So you can use that if you want to type it in. So it's X space, the coordinate, space, Y space, and then the Y coordinate. So here's some tips for other properties we want to add. Besides the pins, we want the silk screen, the assembly top, the package boundary, the package height, and the reference designator. So let's add those now. For the silk screen, we can come down here in this options. We're going to do silk screen top because we don't really need silk screen on the bottom for this. Usually you just put it on the top for the boundary. And we'll select this line drawing tool here. And its default width is 0. So we got to make that something bigger. And I like around an 8, I think. And then we'll just put that by just drawing and clicking the corners. And there's a couple of things we can do here. One common thing is to do a notch like this. And we can right click done. Another thing we could do, if you click on it afterwards, you can right click and do add vertex. And this lets you add some extra points. So you could make it like this, for example. All these pieces are independent, so it's a little funky. Might have to delete some of those and start over. You can always get a new one here, but you could do like a angled corner or something like that. So the next thing we're going to add is the assembly top. You can do that when we do the line again. We're just going to make that square. The next one is the package boundary. And that we go set up areas, package boundary. You can see that kind of fills in once you complete the boundary with some little dots. Next one is the package height, set up areas, package height. And then it looks like nothing happens, but you just have to click on the package boundary. Then it gives you this min height and max height here. So I'm just gonna say like 400 or 10, I guess. Something like that. That's just for the 3D model view. And if you don't give it a model, it'll show it just as like a rectangle. Final one is the reference designator. So layout, labels, and ref des. And I think I like to just put it here and give it a little name like hashtag ref, something like that. So that's about it. It's time to save it. And now it's saved. So we go back to our little folder here. You can see it's all these files right here with this DRA file being the main one. So now let's go back to Capture and link it up. So here we are back in Capture. We double click this guy, and then we just want to add in this, bring this drop down here. We're looking for the PCB designer. And let's do editor, same thing. We're just looking for the footprint. So it's right here. And we called it LM741, I believe. Yeah, here it is, LM741. So we're just gonna put there the name without the extension on it. And this one you don't really have to save. You can just close it out. It stays there. I don't know if this is gonna work. Launch design sync. This is how you go to the board, but we don't have any connections on it. So let's just see what happens. So the board file it's going to make here, it shows as test1.brd. Just hit OK and see if that works. So it failed. Correct the errors reported in the session log. So we can look down here. Here's the session log. So it says exiting. All right, we scroll up a little bit. Here we go, error, pin 1 found in pack short property. So we're back in our symbol here, and it looks like there's actually two things that need to be corrected. One is for the pack short. These actually need to be the names of the pins, not the numbers. So the first one is offset, and then the second one, instead of 5, needs to be offset 2. The other thing is I forgot to add the NC no connect property. So when you have a pin that's not connected that you're hiding, you need to add a property here and just call it capital NC. And in there, you just put the pin numbers that are not connected. So this is going to be pin 8. And you could just put commas with the pin numbers. So we'll save that, go back to our schematic, and right click over here, update the cache. Then we can go back here to launch design view sync, do our updates. Here we are back in the board. So we do place component manually. And here is our component, and then we can now place it down here, and want to hit F6 to complete. Zoom in and see there is our component. So the final thing I wanted to share is if you go to ultralibrarian.com, there's a couple of sites for this, but this one's pretty good. You can type in LM741 here in their search and come up with lots of pre-made libraries. So they show here what models are available, and you want to find one that has preferably all three. That's the symbol, the footprint, and the 3D model. So if we come down here, these guys are a different package. This one here is missing this footprint, so that doesn't help us. This one here is looking promising. Now there it is. It even has a 3D model of the chip, which is pretty cool. It wants to access my virtual reality. No, not going to do that. So now you come down here to download and select Cadence and the 3D model. So we want to get the step file, and they don't have 17.4, but you want the PCB file and the capture file. So those three files. And then you have to register, make an account. Now we've downloaded this file. I'm going to put it in the symbols folder. Unzip it. You can see all these files in here. They have this website guide, so you can open that. It shows how to import the files into Capture and how to import into the PCB editor. Anyway, for the PCB editor, you just run this batch file here and then hope and pray. But what always happens is it doesn't work because it can't find allegro.exe because Allegro is not registered on the path by default. And they explain this in this help website here, that you need to change Allegro to the full path to Allegro here, which is C Cadence SPB in our case 17.4 tools bin and then Allegro. So here is the batch file, and here is the updated path. Save that, run it again. Now it opens up. It says the license has failed. So I think the license failed because I've got multiple windows open here. So I'll close this guy out. Now we'll just try it again. Let's see, I've got this one open too. Close that. Now let's just try it again. It asked me this 17.2 warning a few times. It's sort of automating the creation of the footprint. So now it's made all these files. Do date modified to kind of separate them out. But these are the pad files and then the footprint files here. Now here's the symbol instructions. So you just go File, Import, and Library XML. And on this one, we want to find this new folder we downloaded, OrCAD Capture, and here it is, this XML file. And then it'll automatically make an OLB file with the same name. So we can do OK. And you can see in here it just generated this file. Now we can put that in our project here. I don't think that actually worked. We can add a file to our project. There we go. So here it is down here, and here is the new part. So if we open this guy up here, you can see it's not quite as classy as the one that we made. Look at the part properties. We do have some more things here though. There's manufacturing part number, some extra items, implementation, and a PCB footprint. So that's the name of the PCB file, which should correspond to the files we generated here. Yeah, see it's, I don't know, N08EM, whatever this file is. So that reminds me, on our old 741 that we made, we did not put the footprint in here. So we did it on just the symbol on the schematic. We should have really done it in the library here, like 741. That way, we save that, it'll automatically be linked for every new part that we make in new schematics. Anyway, back to our schematic here. Let's hit P to place a part. And we have our library right here with our new part. Double click that. Now we have this U2 741. And if we save and sync up with our board, we'll see if it's detecting. All right, so we got this warning here that this footprint was not found. So now if we go to place U2, nothing's going to show up here. So we gotta go back to the editor here and go back to our folder. So we need to move all these pad and board files here. I think there might be a couple other files, but we'll do Control X and then just go back here to our main directory, or we'll go into our symbols folder right here. We look at the other symbols we made here, the pads, they don't have too many other files, but this one has a PSM file. I think we need that one too. So we'll go into this new file here, and we have a PSM, looks like 1, 2, 3. We have 3 PSM files, so we're gonna move those over as well. So now if we regenerate this again, we don't get the warnings. We can place manually U2, and there it is. Oh, I always do that. If you don't complete the move, it doesn't place it. So you place it and then right click and do done. There we go. So now we can check out their package versus ours. You can see one of the things they did that's kind of classy is made the first pin a square pad. So the drill hole is still round, but the copper pad is square to make it easy to tell which is pin 1. So we could have done that. You would just have to make a separate pad stack that was square and then just use that one for the first pin and then use the other pad stack for the rest of the pins. Anyway, I think that's about it. This is a lot longer than I meant for it to be, so if you made it this far, congratulations, and I'll see you next time.